Hello, and today we're going to be talking about the distance formula. So we're going to find the distance between 2 points. And the way we're mainly going to do this kind of video is by looking at it in terms of how we can translate this to Pythagorean theorem. So make sure you take good notes because obviously those will always be checked. So this first problem, we're going to set it up just like we would Pythagorean theorem. And the question would actually ask something like, what is the distance between these 2 points? The distance between, I'm going to shorthand here, 1 comma 4 and 5 comma 1. So what this way says is, if we look at it in terms of Pythagorean theorem, let's try to figure out, let's make this into a right triangle. And this point was kind of already put there for you. You won't actually have that point whenever you do these problems. But you look at it and you say that this is the distance. So the distance between 5 comma 1 and 1 comma 1 would be 4. So it'd have that kind of horizontal distance of 4. The vertical distance between 4 and 1 would be 3. So really, if I were to try to find C here, because C is kind of like that distance between those 2 points, C is my hypotenuse, then what I would do is I would just say a squared plus b squared equals c squared, or 4 squared plus 3 squared equals c squared. So 16 plus 9 equals c squared, or 25. Therefore, c equals 5. So here we know the distance between these 2 points would be 5. And we're just going to put it as 5. We're not going to try to put feet or anything like that. If you want to put something to it, you just put 5 units. So really what we're seeing is we're seeing the distance between our horizontal value, our x value, right, that 1 and 5, we found that distance to be 4, and our y value, between that 4 and 1, which that distance was 3. That's how we got our a being 4 and our b being 3. So let's try another problem. Here we say, what's the distance between these 2 points? So really what we're trying to do here is we're going to plot these 2 points first, and then we're going to try to look at it in terms of if it were a right triangle. So our first point is 1 comma 4. The second point is 6 comma 7. So I'm going to draw here a right triangle, and I can kind of count the space and say it's 1, 2, 3, 4, 5 long, and it goes up 3. If I look at my x values, the difference between my x values between 1 and 6 is 5. Between the 4 and 7 is 3. So in terms of what my c is, I would say, well, 3 squared plus 5 squared equals c squared, or 9 plus 25 equals c squared. So c would actually be equal to the square root of 34, right? Because 34 would equal c squared, and then I take the square root. However, we know that c cannot be, the square root of 34 can't be broken down any further, because the only way I can break down 34 is either 1 and 34 or 17 and 2. So that would be the end of that problem. I know this can be kind of confusing, so let's try one more. Okay, so again here we're going to try to create that right triangle. So I'm going to figure out the distance between my vertical distance, or I'm going to kind of draw that right triangle. Almost a perfect straight line. But our distance in terms of, or the distance between our two x values would be 11. This between our two y values would be 5. So I'd have, again, I'm trying to find c here, and in all these problems you're trying to find c. You're trying to find the hypotenuse, so it'd be 5 squared plus 11 squared equals c squared, or 25 plus 121 equals c squared, meaning that c squared equals 146. And that's, let's see if we can simplify that down any further, because obviously we need to take the square root of that to get our final answer, and then we see if I were to divide 176 by 2, all I would get is 73, and 73, I believe, is a prime number. So I can't do anything to get 73. So my final answer would be the distance equals the square root of 146. Okay? So now I'm going to have you pause the video right here, try these two on your own, and when you come back, you will have the answers. Okay, so for your first one, you should have gotten that it was the square root of 10 was the distance, and the second one you should have gotten that it was the square root of 122. If you got those answers, then feel free to move on. If not, make sure to watch the explanation. So this first one, how I would do it is I would plot the point 1, comma 3, which will be x value is 1, y value is 3. The next one has negative 2 comma 4, so that would be to the left 2, up 4. Now it's kind of hard here to make these triangles, but you can see that this one has a height of 3 and a height of 1 and a base of 3. So I would have 1 squared plus 3 squared equals c squared, or 1 plus 9 equals c squared. Therefore, 10 equals c squared, meaning that c equals the square root of 10. The second one, again, I'm going to plot these 2 points, and I'm going to plot negative 2 comma 7, 1, 2, 3, 4, 5, 6, 7. The next one is negative 3 comma negative 4. So negative 3, 1, 2, 3, 4, which is just incredibly cramped there. So here's, oh good, that is one of the worst triangles, but I think you understand the point. It has that base of 1 and that height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be 1 squared plus 11 squared equals c squared, meaning that would be 1 plus 121 equals c squared, or 122 equals c squared. So take the square root of that, I would get c equals the square root of 122. And we can't break that down because it's only divisible by 2 and 61 is a prime number. So let's move on. Because obviously, guys, you're not going to have graph paper every time, right? That's not going to be something that's a practical thing. And in fact, if we can remember a formula to help this kind of figure this out, why not do that? So here, we could draw a right triangle, and let's label the sides A and B. So let's draw our right triangle. So that's kind of our right triangle. And we have to think about this. What would this be in terms of our distance, right? What would A be? What would A be? What would this distance right here be? Well, really our distance is going to be c squared minus, or x sub 2 minus x sub 1, right? This x value minus this other x value. In terms of what's our height going to be, right? What's our quote-unquote b value going to be? I'm just going to take y sub 2, that secondary y value, and subtract it from our first y value, the y value from that first point. So really, if I'm going to be looking at this in terms of a formula, right, I have c squared is going to be equal to x squared minus x sub 1, or sorry, x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1 squared, right? Because this is kind of my new a, and this is my new b. So c squared is going to be equal to that distance, x sub 2 minus x sub 1 squared, plus y sub 2 minus y sub 1. And if I want to figure out what c is, all I have to do is take the square root of everything. So that means the distance formula is this. Oh, sorry about that. Distance formula is this. C equals the square root of x sub 2 minus x sub 1 squared, plus the square root, or sorry, plus y sub 2 minus y sub 1 squared. Meaning we're just going to be taking the difference of these two values. And it doesn't matter if we use x sub 2 first or x sub 1 first, as long as we're consistent throughout it, right? As long as we're trying to figure out the distance between the two. Just kind of like slope, we can't mix those up. So let's try out a problem or two using this method. So here we're going to find the distance, and we're going to say, all right, well, really using this formula, we're going to say that c is equal to the square root of, let's subtract our x value. So I'm going to start off with b. I'm going to say 2 minus 1 squared plus, and I'm now going to have negative 3 minus 4 squared. So that's going to be the square root of 1 squared plus negative 7 squared. And I'm going to put that in parentheses, otherwise I can't do it. So 1 squared is just 1, plus negative 7, the quantity squared, is just 49. So the square root of this would be c equals the square root of 50. And we know that we can break down 50 into 5 square roots of 2 because 50 can be broken down into square root of 25 times the square root of 2. So there we go. Our final distance is 5 square roots of 2. And this method can be a lot quicker if we know how to apply it into a calculator and can do it from there. Let's try another one. So, again, we're going to try this problem. And this time I'm going to use a instead because I really want to show you that it doesn't matter which way you do it as long as you do it the correct order. So c equals the square root of negative 5 minus 2 squared plus negative 3 minus 1 squared. And again, I'm just following this formula that you guys kind of need to memorize so that way you can solve these problems effectively. And you also notice if I were to switch up my x's and my y's, it doesn't really matter in terms of the order, right? Because as long as I'm just squaring both of them, I'm good to go. So negative 5 minus 2, again, that's going to be negative 7 squared plus negative 4 squared. And if I were to do it the opposite order, I would just have positives here, right? But because we're squaring them, it's not going to matter. So this is the square root of 49 plus 16. And if I add those up, that's just going to get me the square root of 65. And I know 65 can't be broken up because the only thing that goes into 65 is 5 and 13. So my final answer is going to be the square root of 65. Now I know what you're thinking. You obviously want to try one, so here you go. Find the distance between these 2 points using the distance formula. Don't use the Pythagorean theorem, use the distance formula because you're going to have, whenever you see this on a test or something like that, you're not going to be given a graph with it. They'll just say, hey, what's the distance between these 2 points? So pause the video here, and when you're done, come